So we know there's an error in estimation of the area using the midpoint rule and the trapezoid rule. So how big of an error that we're expecting? Let f of x be a continuous function over the interval ab, and having the second derivative over this interval, if m is the maximum value of the absolute value of the second interval over the interval AB, then the upper bound for the error using m sub n and t sub n is given by the formulas. Now, I'm not going to prove this formula because it's outside the scope of this class, but you can look it up if you're interested in it. Find an upper bound for the error and estimate the given integral using the trapezoid rule with 6 steps. Okay. So here we know that f of x is equal to 5x plus 4, which means f prime of x is equal to 5, and f double prime of x is equal to 0. Okay. So then the max value of f double prime of x, the max value of f double prime of x over the interval 0, 3 is 0. This means that I can say, okay, then the error in t sub 6 here is less than or equal to 0 times 3 minus 0 to the exponent 3 divided by 12 times 6 squared, and this is 0. So this is saying that if we are using the trapezoid rule to calculate the area under the curve in that given interval with 6 steps, then there's no error. The estimation will be equal to the exact value of that integral. It makes sense though in this case because f of x is a linear equation. So f of x, the graph of f of x is kind of look like this, right? It have the intercept at 4 and the graph is increasing. So if we calculate from the integral from 0 to 3, each of this subinterval is a trapezoid itself. So the area is the sum of each of that subinterval, the sum of that each small trapezoid, then the area is 0. This makes sense. So the Simpson rule. I will not go over the calculation to get to these formulas. You can read more about these formulas in our book. It's written in very detail on how to come up with these formulas. I can tell you though, the Simpson rule is using the area under the curve where the curve that we're looking at is a parabola. So we say that we will use we use 3 points simultaneously, and we say, okay, then I can somehow draw a parabola that go to this point somehow, right? And then I can estimate the area under the curve of this parabola. Then the sum of each of the area would then equal to the total area. Okay. So the formula for this is, let f of x is a continuous function over the interval ab. Let n be a positive even integer and delta x equal b minus a over n. Let ab be divided into n subinterval, each length of delta x with the endpoint at p equal x0, x1, x2 to xn. Then f sub n is equal to delta x over 3 times f of x0 plus 4 f of x1 plus 2f of x2 plus 4f of x3 plus 2f of x4. So you can see that it's alternated between 4 and 2, right? So keep going 4, 2, 4, 2 until the end where you have f of x of n. The error bound for the Simpson rule is based on the fourth derivative. Yeah. So let's take a look at the first example. Use the Simpson rule with n equal 4 to approximate the integral from 0 to 2, the 5x to the 4 dx. So delta x in this case, so delta x is equal to 0.5. And the collection of points that we were looking at is 0, 0.5, 1, 1.5, and 2. Then s of 4 is equal to 0.5 over 3 times f of 0 plus 4f of 0.5 plus 2f of 1 plus 4f of 1.5 plus f of 2. And this equal to 32.5. Excuse me, this equal to 32 and 1/12. Okay. Let's calculate the upper bound for the error in the estimate of the integral. Well, I know f of x is equal to 5x to the 4th, f prime of x equal to 20x to the 3rd, f double prime of x equals 60x squared, f triple prime of x equal 120x, and f to the 4th of x. So that is equal to, so f to the 4th derivative, the 4th derivative of f of x is 120. This means m is equal to 120. So the error in s of 4 or 120 times 2 minus 0 to the 5th divide 180 times 4 to the 4th. And this equal to 8.3%. Excuse me, this equal to 1/12. Okay. So let's take a look at what is the actual value of this integral. Well, the actual value of this integral is the integral from 0 to 2, the 5x to the 4 dx, right? So this is x to the 5th. Evaluate from 0 to 2. This is 32. So as you can see that, compare this value, 32 and 1/12, and this value 32, the error is actually 1/12. So it check out.